Now, if we think the same scenario in a opposite way, instead of instead of removing this negative charge and introducing one conducting plane, just do the opposite. In reverse case, if we have a conducting plane and some charge here, okay, to do this conducting plane and charge, we have some field over here, some field, okay. If we replace this, if we remove this conducting plane and if we introduce the same charge with opposite sign in the bottom side, okay, then the field is same over here. This, if we are introducing the same charge in the opposite side, no, okay, that is called image. That is exactly the image of this positive charge, right? That is called actually the image. This is a technique called method of image. See, if we start with a single charge above perfectly conducting plane, okay, after removing this conducting plane and introducing a negative charge with equal magnitude in the symmetric location below the plane, exactly the symmetric location, okay, and it makes or produces the same field in both the cases, okay. The newly introduced charge, that negative charge, this charge is called the image of the original charge. Image of the original charge, it has a negative value because it should be an opposite sign, okay. So this technique is called the method of image, okay. So simply you remember that what is method of image. Okay, we have a charge, okay, and we have a conducting plane. So due to that, we have some field over here. If we remove this conducting plane and introduce the same charge with opposite sign symmetrically, okay, then also it produces the same field. Okay, so that charge, whatever we are introducing the charge, that is the same magnitude and opposite sign with symmetric location, right? That is called images or image of the original charge. Okay, this is called method of image technique. Okay, hope I think you clearly understand this. What is method of image? Okay, I repeat, we have a charge, positive charge, and conducting plane. We have some field over here. Okay, some electric field density, maybe see some 0.2 volt per meter something. It's magnitude. Okay. Suppose if we replace this, remove this conducting plane and introduce the minus q charge symmetrically. Okay. Then also the same field produced. Okay. This is called method of image. Why it's images? We are introducing the image of this charge. That is the same charge with the opposite sign over here. Okay. This is called method of image. Now, when you solve one problem, you can easily understand this actually. Okay. Take this example. So we have to find a surface charge density, rho s. We have to find a surface charge density at the point P. They are given 2, 5, 0. Okay. So we have to find surface charge density at the point, okay, in the conducting plane z equals 0. And they are given the line charge of 13 nanocoulomb located at the position they are given, x equals 0, z equals 3. Okay. So they are asking to find a surface charge density. This is the scenario, just imagine. They are given a line charge of 13 nanocoulomb at some particular position. Okay. And they're asking to find a surface charge density at some particular point on the conducting plane. Just remember that sentence. Now you can get the picture. Okay. See, this is a conducting plane. This is a conducting plane. So they are given the line charge is located at x is equal to 0, z is equal to 3. Z is equal to 3. So 1, 2, 3. This is a line charge, 13 nanocoulomb per meter. Now we have to find a surface charge density at this point 2 comma 5 comma 0. You just imagine a three-dimensional view. Okay, in x-axis 2 unit. Okay, y-axis 5 unit. This is actually a z is equal to 0 plane. This is placed alongside equal 0 plane. So z is equal 0. This point we have to find a surface charge density. What is the surface charge density? Okay, due to this line charge in the conducting plane. Now, apply a method of image technique. What method of image says? We can remove this conducting plane, okay, and we have to introduce the image of this line charge. That is exactly equal magnitude, 13 nanocoulomb per meter, but opposite sign symmetrically. Okay, so we replace this configuration with the configuration B. We removed this conducting plane. We introduce the same line charge, minus 30 nanocoulomb per meter, exactly that same magnitude, opposite sign, symmetrically. Okay. Now we can easily calculate the surface charge density. Okay, easily the given point. First, you know the formula to find out the electric field intensity, right? How do you find the electric field intensity due to line charge? Do you remember the formula? Can anyone say the formula? Electric field intensity due to a line charge.
So rho L divided by 2 pi epsilon naught rho.
Yeah, very good. Rho L by 2 pi epsilon naught rho. So rho L is a line charge. Okay. Rho is a distance excited. Now we just okay. Now first find okay the electric field due to the line charge of the positive side. This is 13 nanocoulomb meter. Okay. You know the formula. Rho L by 2 pi naught rho is the side distance between the line charge as well as the point where you are evaluating the field. Here we get the R. Okay, so the same. Now rho L is issue given as a question. 13 nanocoulomb. Okay. 2 pi epsilon naught. What is the R? This distance between the line as well as the point P where we are going to measure a field. How to find this distance? Okay. From the x-axis, see a little bit careful here. Sometimes we may confuse the positive or negative. Okay. So this R plus. This is the distance, right? Okay. You see the x-axis that's at 2 units, 2 AX. So it varies from the positive direction, 2 AX, 2 AX. As it lies, the line charge is lies along y-axis. We don't have any y points. Okay, I think you know that. From Z, you see 3 units, 3 AZ. Whether it's plus 3 AZ or minus 3 AZ. Anyone? What I am explaining is the distance R plus. Okay, that is we are finding the distance between this line charge as well as this point. Okay, so simply in x-axis it has a 2 unit, so we can represent as 2 AX. Okay, Similarly, along Z axis, it's 3AZ, right? I'm asking plus 3AZ or minus 3AZ?
Minus, sir.
Minus. Why it's minus?
Sir, from the line charge we'll see, and from the line charge it's going along the negative z axis.
Yeah, very good. Super. So, sometime we may confuse that this is in positive Z axis. So, we may put plus 3Z, 3AZ. No, actually, the line is moving from Z axis to downwards. So, through negative. Okay. So, 2AX minus 3AZ. That is the distance of R plus. What is R plus? 2AX minus 3AZ. Actually, 2AX vector minus 3AZ vector. Similarly, so when you substitute this R plus over here, okay, so you can find the answer. And also don't confuse with that. What is AR plus? That is actually the unit vector, that is R vector by magnitude of, that is R plus vector by magnitude of R plus vector. So 2AX vector minus 3AX vector by its magnitude. Already there is the magnitude. So we can have the cancel of this root then 13. Okay, I explain here. See, rho L by 2 pi epsilon R plus AR plus vector is a formula. R plus is the distance between the line charge as well as the point in magnitude. Okay, what is AR plus vector? It's actually a formula, you know that this R plus vector by magnitude of its R plus. Okay, so R plus vector is 2AX vector minus 3AZ vector by its magnitude root 13. This R plus actually root 13. So we calculated the field due to the line charge that is located in the positive Z axis. Now similarly, we have replaced with the same charge with opposite sign as per method of image technique, right? Now calculate the field at the same point due to this one. Okay. Now what might be the distance? Anyone? Like we have calculated this R plus, no. Like that, anyone? R minus? Like this 2AX minus 3AZ. When you calculate that, okay, it's actually in the x-axis, it's actually again same 2AX. Okay, in Z, see, we are moving from bottom to up. Okay, towards the positive Z axis. So it's actually plus 3AZ. Okay, so R minus is 2AX vector plus 3AZ vector. Any doubt in this distance? Sometimes it may be a little bit confused here. If you have doubt, you just ask here. I will explain and go next. Okay, I think no doubt. Okay, so R minus is 2AX vector plus 3AZ vector. Okay, so when you substitute this, okay, we can calculate E minus. Okay, so E plus is the field intensity due to this 13 coulomb per meter, this line charge. E minus is the field intensity due to minus bottom side. This line charge. Okay. So total field over here, that is electric field intensity, is by simply adding this together. Okay. And also don't confuse here. this is actually minus 30. Okay, this is actually a minus 30. So minus 30. When you add together, everything is same. Only difference, this become minus 2ax, this become minus 3az. So minus 2ax plus 2ax cancelled, then 3 become minus 6. When you multiply over here, you will be getting this answer. Minus 249 AZ vector volt per meter. This is actually the electric field intensity, okay, at the point P. So we know the relation between D vector and E vector. D vector equals simply a epsilon naught E vector, which is equal to minus 2.20 AZ vector nanocoulomb per meter square. Okay. Now what they are asking, actually they are asking to find a charge density. Charge density. It means we know that, okay, the total flux or field lines exactly equal to the charge. Okay, that is simply the minus 2.20 nanocoulomb per meter square. As we know the law, okay, the total field lines, okay, is exactly equal to the charge. So the charge density is calculated from D vector, so it's same actually minus 2.20 nanocoulomb per meter square. What we did here is they are given the scenario as one conducting plane that is lies in the z equals 0, okay, and one line charge 30 nanocoulomb per meter, and they're asking to find a charge density at this point. Now what we did, we applied a method of image technique, so we removed this conducting plane, okay, and we introduced one more line charge symmetrically with opposite sign here, okay, and we calculated the electric field intensity at the point due to this line charge, okay. Similarly, we calculated electric field due to this line charge, and we added together, okay, and calculated the electric flux density through this formula, okay. So as per the law concern, the charge density is exactly equal to the total field lines, so which is equal to minus 2.20 nanocoulomb per meter square. Okay. This is about application of method of image, and I think hope you know that what is method of image also I explained. We have some simple example you can understand. See here, this is a conducting plane. We have charge with magnitude plus 1 minus 4 here. Okay, if you remove this conducting plane, if you introduce same magnitude with opposite sign minus 1 minus 4 plus 4, okay, then both the configuration are same. Both are same. This is actually in terms of some value. Okay. Okay, any doubt in this? Yeah.
Flux density and charge density, how are they same, sir?
Actually, in Faraday's law, we find no. Actually, we they took one inside sphere. Faraday took one inner sphere with some Q. Okay, and there is an outer sphere. They found that there is sort of an flow from inside inner sphere to outer sphere. That field lines, that flux, exactly psi is equal to the charge Q. This is what we discussed in the class. No, same thing here.
Sir.
Okay.
Always, sir, like that.
What?
Will be like that, sir. Like it feels like they are two very different things, but then they are equal. A bit uncomfortable. I don't know. Sir, is this like this only in the in magnetic, sorry, in electromagnetic only it's like this, or in all other
Yeah, it's a general, not only the electromagnetic. This is if you have a line charge, okay. If you have the line charge density, we find a field. This is applicable. Generally, in physics, it's applicable.
Can you say like if gravitational flux is there?
Do you know any relationship between this D and Q? Electric flux density D and Q?
D and Q.
Yeah.
I don't know. Electric field I can write in terms.
Okay, so you just see here. This actually in Gauss law and application, you would have studied this one. I don't know whether you come across this. The formula is the surface integral of d vector dot ds is equal to q. Surface integral of d vector dot ds is equal to q. Simply, electric flux density in a closed surface is exactly equal to the charge. Okay, that's what applied here.
Yes, sir.
Yeah. Any other doubts from any other persons? Method of image, and also based on the method of image, we solved the problem. Okay, then we go with the problem solving session. Everyone be just ready. Okay. First we go with the problem. Yeah. Okay. All of you know this problem. In free space. Okay. In free space, the electric flux density D vector given. Okay. Some quantity in terms of Coulomb-Vertex. The first formula, find the total electric flux passing through the rectangular surface. The particular surface they are given. Z is equal to, and X varies from 0 to 2, Y varies from 1 to 3 in the AZ direction. Okay. I think we know clearly the electric flux is simply psi. We represent psi, which is equal simply a Q. Okay. How to find? Do you have any formula to find this? They are given D vector, electric flux density. They are asking to find a total electric flux passing through this rectangular surface. Is that equal to 0 to 2, X, Y, 1 to 3? Do anyone have the idea? Any formula?
Sir, D is equal to 5 by A.
D is equal to
5 by A.
5. What is 5?
Electric flux, sir.
We don't know electric flux here, right? Yeah, that's what we are going to find. Yeah. Okay. Very good. Okay. That also you can apply. D is equal to 5 by A. So 5 is equal to electric flux equal to area into electric.
Sir, but directly we can't multiply, sir. We'll have to integrate.
Yeah. Any other formula? Just now I explained no. The surface integral of the electric field intensity d dot ds is simply equal to the
V.
electric flux psi. There is the formula. So don't confuse with this q. Q is equal to psi. Actually, we do represent the electric flux as psi. Okay. It's not coming properly anyhow psi. Okay. So both are same. So don't confuse that. Okay. Apply this formula and find out. Everyone just work out it. Similarly, the option B. After finding this, how do you find option B? Very simple. They are asking to find the electric field intensity at some particular point. How do you find? It's very easy. I think you can get the answer quickly. Anyone?
D is equal to epsilon naught into E.
Yeah, very good. D is equal to epsilon naught E vector. They are given D vector. So simply you can find E vector. All of you just take a snapshot of this. Okay, then try to work out. I will call anyone randomly. Okay, so everyone be ready with that. I think surface integral you can easily define. Okay, they are given as Z is equal to. Okay, the rectangular region. Just draw a rectangular region. Okay, so only the variation is x and y, 0 to 2, 1 to 3. So ds become dx dy. Okay, so the x and y variation they are given. So z is equal to, directly substitute equal to, and simply integrate. And one more important point, you should be very careful. D vector, you know this. What is ds vector as per this concern? Dx, dy. What is the unit normal vector here? Unit vector. In the vector system, I explained no. ds is equal to,
Dx dy is dz.
yeah, dx, dy. What is the unit vector? What is the unit vector here?
DZ, sir.
What?
Z.
Yeah, very good. That is they are given in they just simply z is equal to, and we have to find this along z direction, right? So a is z. Whatever there is, here x is there, y is there. What is the remaining? A is z. Simply that a is z vector. This is basic, no. When you substitute over there, so d vector dot this one, you will be getting only this part, because a is z dot a is z is one, remaining time vanishes. So this value and integrate with the given surface region. Do this. Do this and give me the answer. Hope I think you noted the problem. Shall I close this? Otherwise, you just note this. Simply write d vector and this surface area region, rectangular surface. So the option is to find a electric flux in the surface, rectangular surface. Okay, due to this electric flux density. Okay, the option B is electric field intensity at particular point. Okay. Roll number one, Durga.
Yes, sir.
Yeah, what is the option A? I have given the question.
Sir, I'm doing, sir.
No, no, I'm not asking the answer. What is the question? Option A, what you have to find? Durga, you are muted.
Sir, sir, to find the total electric flux, sir, through the rectangular surface area, sir.
Yeah, okay, okay. Yeah, do. If you don't find the answer, you can post in the chat box also. No issue.
Sir, I got something 1365 around into
One.
10 to the power minus 22.
Okay, let me check. Let me check. Okay, you just put your answer. Finally, we will check. Sanjay Reddy got 1514.66. Okay. Sanjay told 1395 something. Yeah, 1365. Okay.
Sir, 1365 into 10 to the power minus 12 coulomb.
Minus 12. Okay, okay. You just put exactly the correct answer. Into 10 power minus 12 also you can. If suppose if you can't put 10 power, just 10 side, you just put minus 12 in chat box. No issue. With the unit also, you just try to put the answer. Then only the flow will come in your examination also. 1365 10 power minus 12 coulomb. Winston, yeah, yeah, no. The same answer did you
Yeah,
get?
yes, sir. Same answer.
Okay, okay, then we will check. What about others? See, this answer may be right or may be wrong. Sanjay Reddy also opposed one answer. That also may be correct. Okay, you just do your own calculation, you just post. Finally, we will confirm the answer is correct. In the last class exercise problem, I think 8 of you posted in the group. Yeah, I noted. Good, okay. Roll number 15, Kalidas. Why Kalidas left the meeting? Reshma, roll number 40.
Yes, sir.
Yeah, Reshma, I think, are you there? Okay. You are there. Good. Are you solving the problem?
Doing.
Okay. Do you just you post it?
Sir,
Yeah. Yeah,
sir, I
Sandeep,
got
yes.
E is equal. I got the E at point P2 comma
Okay,
minus
okay.
1
Let
comma
us so
3
just
at
post here. Okay, good. Sanjit went second option B also. Very good. Okay. What about others? Only 3 or 4 are only responding. Roll number 45.
Yes, sir.
What are you doing?
Yes, sir. Doing,
Yeah,
sir.
okay, good. Yeah, okay, okay. Roll number 51, Srinidhi.
Yes, sir.
A very simple question, Srinidhi. What is capital E vector in this electromagnetics? Capital E
Electric
indicates
field.
electric.
Field vector.
Okay, electric field intensity. Okay, Srinidhi, good.
Intensity.
Okay.
Yes.
Yeah, good. Okay. Roll number 64, Adrita Saha left the meeting. Okay. Sanjit answered option B also. Okay. Okay, Winston Das and Sanjit. Pavitra also answered. Okay. Yeah, very good. The answer for option A is what you are answered, most of you. 1365 10 power minus 12. Also, we can represent as pico. Right. Okay. So 1365 pico coulomb. We know the unit for flux, that is coulomb. Yeah, very good. So the answer for option A is 1365 pico coulomb. Okay. So option B, try to solve the option B. Sanjit only posted. Let me check the answer is right or wrong. Yeah, for option B, the answer what Sanjit has posted is exactly correct. Okay, minus 146.4 AX vector plus 146.4 AY vector minus 195.2 AC vector. Yeah, very good, Sanjay Reddy. Same thing. Good. Okay, so the unit is volt per meter, the electric field intensity. Okay, the same question, the option C, actually, they are asking to find an approximate value for the total charge contained in an incremental sphere located at the point 2 comma minus 1 comma 3 and having a volume of 10 power minus 12. This option C, what they are asking is, they are asking to find an approximate value for the total charge contained in an incremental sphere located at the point they are given 2 comma minus 1 comma 3, and they are giving the volume 10 power minus 12. Okay, so how to find this? I give the formula here, you just note down. So they're asking to find a total charge contained in an incremental sphere located at the point and having a volume of 10 power minus 12. Okay, the formula here is charge enclosed in a volume del V, that is actually incremental sphere. Okay, this equals simply a divergence. Okay, dou dx by dou x plus dou dy by dou y plus dou dz by dou z into what is the volume. Volume they are given as 10 power minus 12. You know d vector. From that, you just got dx. What is dx? This part, no. Simply you differentiate this part with x plus this part with y plus this part with z and multiply with the given volume. Then you can find a charge enclosed in a volume. Note this formula, then you can find this. Okay. With the option C, okay, we end the session today. You just try to solve the option C. And also, if you feel any difficulty in solving problem, also you can ask others. Maybe someone may don't know how to do this surface integral. Okay, anyhow, this is direct substitution. Directly, you know the exponent value, and you multiply with divide with this d vector. Then you can find e vector. No issue, I think. If you have any doubt in this surface integral, you can ask. Okay. Those who did this option A and option B, go with option C. This is the formula to find a approximate value of total charge contained in incremental sphere. Okay. And they are given the location. You just note this point 2 minus 1 3. You have to substitute this xyz value also here after doing this operation. Okay. Don't substitute before this point. After doing this divergence operation, dou d by dou x, then you substitute this point 2 minus 1 3 and multiply with this value 10 power minus 12 meter. I think noted everyone. I just stopped sharing. Okay, Sanjay Reddy also answered minus 8y. Yeah, very good. You just substitute that point, Sanjay Reddy. Then you can get the answer. They are given the
Okay,
xy is
sir.
at point, right? If you substitute, you will be getting the answer, correct answer. Do anyone got the answer for option C? If anyone get, we will end the session.
Sir, I got something, but I'm not sure.
Okay, we just put the answer, no issue. Whether this is right or wrong, this we are doing, no. So if it's wrong means it's not bad. Okay, you are doing. That's all. Minus 2376 10 power minus 24. Sanjeev. Same thing posted Pavitra also minus 2376 pico 10 power minus 12 minus 1080 pico. But in 10 power only some small changes will be there. Okay. Okay. The option C is what Sanjit has posted. Okay. Minus 2.3 into 10 power minus 21 or minus 2376 10 power minus 24 coulomb. Okay. Actually, the answer is minus 2.38 into 10 power minus 21 minus 2.38 10 power minus 21. Same thing. Sanjit is correct. Okay. But I don't know. Many of you got 1080. Where did you made a mistake?
Sir, don't know, sir.
Sir,
I
I
think
think they have
after
to, they have,
differentiating only, you have applied you substituted the point, right?
Yes, sir. Yes, sir. After differentiation, substitute, sir.
Okay,
sir,
then
I think
why?
they
Because
have put it the,
Vamsi also posted the same answer. Okay,
Yes, sir. How do we get that 10 power minus 24, sir?
10 power minus
10 power minus 12, 10
24.
power minus for each and every.
given. Listen, in the questions of they're given pico 10 power minus 12. Okay,
Yes, sir.
and you have to multiply with the volume del V.
Oh,
Into
okay, 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 sir.
that also given in the question. No,
Yeah, yes, sir.
like
Yes,
10
sir.
power minus
Okay,
12,
sir.
10 power minus 12 became 10 power minus 24.
Sir, I think they got 1080 because they have instead of writing rho dz by dz as they written as plus 1728, I think, but it should be minus 1728.
Yeah, it's minus 178. The second term will be positive, I guess.
No, 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 both will be
So
negative.
yeah, yes,
Minus
sir. Yes, sir. Sir,
178.
I got the answer, sir. Yeah, second time I took positive by mistake.
Okay, okay, okay. Okay, I think same
Now
mistake
I
did
got the
by
answer, sir.
Vamsi also. Okay, you can correct. Yeah.
Yes, sir. Same mistake.
No, Pavitra, you don't have to square. Okay, I just again show the formula. Then you
Yes,
can
sir, I
understand.
got it, sir. In D itself, it is pico.
Yeah. Uh, here in D we have picocoulomb, so 10 power minus 12. So you'll be having 10 power minus 12. The volume of del V given 10 power minus 12. Okay. So 10 power minus
Yes, sir.
24
Yes.
you will be having, and after simply a differentiate with respect to x, y, z, and substitute the point 2 minus 1, 3. That's all.
Sir,
Yeah.
for what all they are using row, sir? For everything they are using row. It's confusing, sir.
Where the term you are saying about the term rho.
Row they are telling distance also, linear charge density also.
Yeah, that's actually, see, we have many textbook. No, each
Yes,
author
sir.
used some term to represent it. Some people used R to to denote the distance between the charge and the field measuring point.
Yes,
Some
sir.
people they use rho.
Uh,
Okay, and also in a cylindrical coordinate system, we have a one of the parameter as rho. That is
yes, sir.
radius of the cylinder.
Uh,
Okay, so based on the problem, we can understand actually what is rho.
yes, sir.
Okay,
Sir, that del dot D equal to rho, that is charge density, yes, sir. Rho.
which one? Yeah,
Del
rho.
dot
Yeah, rho
D.
actually charge density. Yeah, rho we use distance for some case as well as a charge density. So rho S means surface charge density. Rho L means line charge density.
Uh, okay. The del dot D one is volume charge.
Del V is actually that is a incremental volume.
Sir, del dot D, sir.
Del dot
Del
D.
dot D equal to rho
Rho,
E1,
yeah,
sir.
that is actually the divergence of electric flux density is exactly equal to the charge. That formula, the rho indicates as charge.
Charge per volume, I think, sir.
Yeah,
I think that's
charge
what we are
density. Yeah,
using. Okay,
del
sir.
dot D is equal to rho, charge density.
Yes, sir.
Okay, hope you are doing, some of you. Okay, but I think some of you, I don't know whether you are here or not. Anyhow, uh, at least try to respond when I call someone. With before ending the class, I think 5 people are left. Okay. Hmm. Okay, last one person we call 56. What do you argue? What do you argue? Are you there?
Sir, bad, sir, came, sir. He left,
Oh no,
sir.
your class.
He's here, sir.
Okay, okay, okay. Yeah, then we meet in the next class. Okay. But sir, sorry, sir. I don't think there was lunch time.
Okay, no problem.
Okay, sir. Thank you.
Thank you, sir.
Good afternoon, sir.
Good afternoon. So now today we will start our second unit, second topic. First topic we have already discussed how to solve the differential equation using Laplace transform. Okay. Today also we will discuss how to solve the differential equation. Okay. Simultaneous differential equation. Okay. So preliminary discussion first I will start. Before that I will share my my screen. Is it visible?
Yes, sir.
Okay. Differential equation. Okay. So you already know how to solve differential equation using different method. Okay, different techniques. So differential equation. So our target to solve the differential equation here in this class. Okay, using Laplace transform. Okay. So first ordinary differential equation. Okay, with constant coefficient. Constant coefficient. Okay, that one we have already discussed. Okay, that means a single differential equation with constant coefficient like that. What is dy by dx equals to or dy by dt equals to. Okay, f of t, this one or else. Okay, this is one or else. Dx by dt. Okay, or 2x by 2 plus dx by dt plus x square of dt. This is okay. So here, for this case, y is the sorry, for this case, y is the dependent variable, dt is the independent variable. Okay, this is true. Here it is x is dependent variable, dt is independent variable, and this is these forces. So all the coefficients of the differential operators, okay, that is here is 1, that is 4, that is again 1, that is 50, and it is independent. So all the coefficients are constant. Okay. But if you write x square dx, okay. So instead of 1, if you write x square, so x square, or if you write t square. Whatever maybe. So if x square are reality t, okay, the coefficient for this case only you can write dy by dt, but this dt multiplication you can write like that. But if it is x multiplication, sorry, y multiplication, y into f of t, sorry, y into dy by dt, then you can't write that dy by dt equals to f of t constant. That means dy, okay, y equals to f of t dt. Okay, this is the and then the coefficients are variable for that case, not constant. Okay. Right now, we will not consider such type of problem. We will consider only the differential equation with constant coefficient. That means only constant coefficient. That is the actually your syllabus. Right now, we will discuss this one. Like time permit or some other cases, we will discuss. Okay, that with variable coefficient. Okay, this type of differential equation we have already discuss. Okay, now using Laplace transform, how to solve Laplace transform using Laplace transform. Okay, we have already know that solve. Okay, the given differential equation. I will not solve this one. We will not solve this one since we have already studied that one. Just for your information, solve the given differential equation. What is that ordinary differential equation? What is that? Now dx by dt, okay, plus, okay, plus 5x equals to e to the power minus t. If I if you have to solve this one, sorry, if you have to solve this one, okay, using Laplace transform, you need only one condition. Okay, since it is one that only one that order is one. Okay, first order differential equation, correct? So if you have to solve that one, already we have discussed. If you have to solve this one, this type of differential equation, say 5 dx by dt plus 6 x equals to e to the power minus t, then you need two conditions. Okay, two conditions, but in this case one condition. Okay, so if you have that one, then you can solve using Laplace transform. Now if you have two differential equation, that means this one, first one, dx by dt plus 5x equals to e to the power minus t, another equation dy by dt arbitrarily, okay, now plus say 4y equals to e to the power t. Then you have to solve this one. This type of equation is known as, what type? Two equation are there, that means two dependent variable x and y and only one independent variable t, correct? This is the type. So x and y are dependent variable, colon t is the independent variable. So this set, okay, this set of equation, okay, is called system of equations. Now we will study this one, how to solve the system of equations. Okay, so another name is there. Can you tell me the name of that one? What is this one? 5x plus 4y equals to 10. Okay, 3x plus, okay, 2y equals to say 15. What is this? System of
Linear equations.
Yeah,
Linear equations,
linear
sir.
equations. Okay, good. Linear equation. So two variable only. But what about this one? That system of equation. Okay, system of linear differential equation. Correct. And just for this case, all the coefficients are constant. Okay, nothing is there, so it is 1. Okay, so according to your syllabus, linear differential equation with constant coefficient, and since number of equations is more than 1, then it is called system of linear differential equation. Okay, linear differential equation with constant coefficient. Okay, constant coefficient, correct? So we will study this one. Okay, so and this type of equations, okay, differential equations, if it is more than one equations with two dependent variable, one independent variable, you can say that is simultaneous differential equations. Okay, so now that directly we will consider one problem and we will solve. Okay, now so example say first one, you should have pen and paper. Okay, since lot of calculations are there. Okay, and I can't write all this, means you have to solve that one. Ordinary solution of two algebraic equation I should not do. Okay, now you should answer that one. Solve the simultaneous, okay, first order okay, first order differential equation, for t greater than equals to 0. This is the, now I will write the differential equation. Dx by dt, okay, plus dy by dt, okay, plus 5x plus 3y equals to e to the power minus t, right hand side f of t, 2 dx by dt, okay, plus dy by dt plus x plus y equals to 3. So this is the system of equation that is called simultaneous first order differential equation with constant coefficient. Of course, all the coefficients are constant, 1, 1, 5, 3, 2, 1, 1, 1. Okay, so that is these are the coefficients. Okay, first order, then how many conditions you need for this to solve this simultaneous equation? Forget about Laplace transform. Okay, now. So till now I have not written solve the difference for solve the simultaneous first order differential equation for t greater than equals to 0. I have written. So I have not till now I have not mentioned here anywhere that that it is Laplace transform. Okay, these two. So now before that you just tell me how many conditions are required for this problem.
2, I guess, sir.
Why?
Because it involves 2 different variables and it is only of first order.
Yeah, so first order, but 2 variables are there, correct? So 2
yes,
conditions, so 1 each for each variable. You are correct. Okay, now. So if it is second d2x term is if it is d2x by dt2, this term in actually include then d2y by dt2, both are included, then 2 for y, 2 for x. So 4 conditions are required, correct? So now for this one, okay, this one subject to the initial condition, IC, initial condition. Okay, so for 1 for x, 1 for y. So x equals to 2 and y equals to 1 at t equals to 0. This is the problem. So now the problem is completed. Solve using, now apply Laplace transform formula. Okay, now, or apply Laplace transform. Okay, solve this one using Laplace transform. Okay, so now here it will solve the simultaneous ordinary equation for the using Laplace transform. For this subject is okay, no need to mention also, you can directly apply the Laplace transform. But for general actually examination, okay, if it is not mentioned, you can solve using anything, any method. Okay, now solution procedure. So how to solve this type of problem? Okay, solution. Okay, what you have to do, like earlier, okay, what we did for the ordinary differential equation, when we solved that one, that time what we did, now equation, differential equation, take the Laplace transform. Okay, Laplace transform, then this is the Laplace transform from that outcome. Okay, Laplace transform of differential equation, take the inverse Laplace transform, then you will get the solution in term of x of t or y of t. Okay, so here it is, what will be the solution if you our target to solve this differential equation. Now our we will get this type of solution, x of t one set, y of t another set. These two set combined is called actually the solution of the given system of ordinary differential equation, or you can say the solution of the given simultaneous ordinary differential equation. So our target is to find x of t and y of t. Okay, since x and y are the dependent variable and the independent depends on the t. Okay, so what is that one? Now taking, so first term, okay, now Laplace transform. Okay, taking Laplace transform. Okay, taking Laplace transform of 1. Okay, we get, tell me the Laplace transform of dx by dt. What is the answer?
Yes, f of s
Okay.
minus f of 0, sir.
Now since 2 variables are there, so x of t, the Laplace transform notation is say capital X of s, and y of t Laplace transform, and the notation is say y of s. So you can distinguish 2. Okay, now. So your answer is, I understood, s of x of s, okay, minus, okay, x of 0, small x of 0, for the case of this one. Okay, so now what is the Laplace transform of this part? So this part is plus, okay, s of y of s
Yes.
minus y of
Minus
0.
y of
Correct.
0.
Now the third term plus 5x. So plus into, that is, what is that? S of s, correct? Plus 3 of y of s, Laplace transform, equals to e to the power minus t. What is the Laplace transform of e to the power minus t?
1 by s plus a.
Okay, s plus a. Why it? Where it is a? 1, na?
1 sir. Yes
Okay.
sir. S plus 1.
Correct, correct. Your formula is correct. So now, second equation. This is the now you have to find the Laplace transform of the second equation. So second equation is twice, okay, s of x of s minus x of 0 plus s of y of s minus y of 0, okay, plus x of s plus y of s. What is the Laplace transform of 3? Laplace
3 by
transform
s.
of 3 by s. So 3 by s. Okay. So this is the Laplace transform. Okay. These are the Laplace transform. If you take the Laplace transform of the given system of equation 1. Now you have two conditions. You just check it. Two condition. Okay. One is this one. Another one is this one. At t equals to 0. What is the meaning? The x of 0 equals to 2 and y of 0 equals to 1. So these are the two conditions. Okay, so now what is the next step? I have to go to the next page, but before that you should write. Okay, now add on applying, okay, the given initial conditions x of 0 equals to 2 and y of 0 equals to 1, we get x of 0 equals to 2 and y of 0 equals to 1. So this is these are given. So underline are given one. Okay, you have to substitute these values. Okay, so x of 0 is 2 and y of 0 is 1. So if you put this one, okay, then the total system, this system, okay, will reduce to capital X of s, capital Y of s and s. No other variable will be there or no other part will be there. Okay, s, capital X of s and capital Y of s. That are the three part will be there after substituting the. Okay, so I will go to the next page. Okay, so here. So what is that? Now substituting the given initial conditions, we get. So you just tell me, and after that, what will be the answer? Actually, s x of s, okay, minus what is x0 is 2, okay, 2 plus s y of s, okay, minus 1 plus 5x of s, okay, plus 3y of s equals to 1 by s plus 1, and another one is twice, okay, s of x of s minus 2 bracket close plus s y of s, okay, minus 1, okay, plus, okay, x of s plus y of s equals to 3 by s. This is okay. So now if simplifying we get, okay, now if you simplify or rearrange, okay, if you simplify, okay, simplifying we get what is that one? So first one is just see, okay, s plus 5 into x of s, okay, plus, okay, y x plus 5 this one, and then s is s plus 3 y of s, okay, y of s. So now minus 2 minus 1, so minus 3 plus 1 by s plus 1. Am I correct? S plus 1 by, correct. So similar case, okay, what will be the next one? Next one is twice s plus, okay, 1 x of s plus s plus 1 y of s. So 2 into minus 2, minus 4 or minus 1. So minus 5. Minus 5 means 5 plus 3 by s. So this one is 3s plus 3 plus 1, 4 s plus 1. This one is 5s plus 3 by s. This one. So this is equation 2. This is equation 3. Okay. Now you have to solve. That means if you are able to find x of s, x of s, okay, in terms of say f of s, then easily you can find the x of t using the inverse Laplace transform. And similarly, if you are able to find from 2 and 3 y of s equals to g of s, then you can easily find y of t. Okay, you can find this one. So this is the actually this 2 and 3. Okay, these are not differential equation. Okay, so 2 and 3 are two algebraic equation. If you consider x of s is one variable and y of s is another variable. Okay, so now you just check 2 and 3 are not at all differential equation. So from the differential equation using Laplace transform, you converted that to ordinary differential equation to two algebraic equations. Correct, 2 and 3. Now this is your work. I will write only. Okay, now solving. Okay, or solving the algebraic equation. This is our algebraic equation. Okay, now two algebraic equation. Solving the algebraic equation. Your answer now task is to solve these two. Okay, now these two equations. Equations 2 and 3. Okay, for x of s and y of s. Okay, so y of s, correct, we get. Now you have to answer s of x is what in terms of s and y of s in terms of s. So this is now your task to solve x's and y's. Quick, but I know it you need some times, but this is very simple one. You'll eliminate by multiplying something, eliminate y of x first time, and the second time eliminate by multiplying something, just algebraic equation. Eliminate by multiplying something, you just eliminate x of s. So 2. Okay, this one I need this one from odd, and this one, this sorry, not this one. This is for odd. This is for even. Quick. So you know why I am writing even or odd, so that we can minimize the time. Okay, now. Otherwise, if you have to solve both, it will take a lot of time. Quick. X of s, y of s. I think you people are here only, not going for lunch. You find the answer in this form: s into s plus 2 into s minus 1. What is the numerator? For the case of even also, even roll number. Numerator, you have to write s minus 1 into s plus 1 into s plus 2. This is the S plus 2, sorry, last one. Tell me the numerator only.
Sir, x of s numerator equal to 2s square plus 14s plus 9.
Okay. So s square 2s square plus 14s plus 9. Okay, that's okay. So now I'm waiting for the even roll number. What is the numerator? So it is 4. This one is 5. Numbering. So 4 and 5. Even roll number, what is the numerator for y of x? Yeah, a little bit tough for the even. So you understood the steps. First Laplace transform, then you will get the algebraic equation. Solve the algebraic equations using your known techniques. Okay, that so many techniques you have studied the 12th standard. Okay, so elimination, etc., etc. Okay, na? So based on that, yeah, Dharma, elimination. What they are telling?
Now they simply say don't make this.
Oh,
But I think including picture, I think.
then. So should I write? You are taking a lot of time. Okay, I will write then. Okay, the answer is s cube minus 22s square minus 39s minus 15. Okay, so this is these two are the x's and y's. So you know that x is nothing. Okay, what is that? That is actually the Laplace transform of x of t. Okay, and y of s is Laplace transform of y of t. So if you have to, this one is now you have this one with you right now. So you have to find this one. That means you have to use inverse Laplace transform. Here also you have to use inverse Laplace transform to get that one. So this is the third step now. First step, take the differential equations, Laplace transform of the differential equation, given differential equation. First step 1 completed. 2, solve the algebraic equation. Okay, transformed algebraic equation. From where you got that transformed that one algebraic equation using the Laplace transform. Third step is now you have to take the inverse Laplace transform of 4 and 5. Then you can find x of t, y of t. Okay, so now first to get at a time you can't solve both 4 and 5. So first we will consider this one 4. This one is the second step. Okay, so new, what is x of s? 2 square plus 14s plus 9. Okay, 2 square plus 14s plus 9. New base. So 2 square plus 14s plus 9. This one is known. S minus 1 is S plus 1. Okay. Sorry, S plus 2. So this one. So this is X of S. Okay. So what is the next? Now you have to write here solving first for X of S. X of S. Solving first for X of S. Okay, this one, this step. So X of S is this one. Now, so you know how to solve this one. What is the procedure? So you have to do what? Partial fraction, correct now? So write down resolving into partial fraction. Partial fraction. We get X of S. So what is the partial fraction? Since it is denominator is numerator or 2, order 2, I mean, highest power 2, denominator 3 fraction. Sorry, 3 factors. So it is straightforward. So you can write A S minus 1 plus B S plus C S plus 2. Difference is 1. So directly you can write. Okay. So now if you write this one, okay, the answer is S minus 1 is 25 by 3, S minus 1 A. So these few steps are there. Okay, now find A, B and C. Okay, so A, B, C, the answer is like that, plus minus 9 by 2 by S plus minus 1 by 6 by S plus 2. So what is the answer? Now 25 by 3 into 1 by S minus 1 minus 9 by 2 into 1 by S minus 1 by 6 into 1 by S plus 2. All are standard one. Okay, right hand side. Okay, now taking inverse Laplace transform, okay, we get X of t. What is the answer? 25 by 3 into 1 by S minus 1. 1 by S minus 1. Quick, 1 by S minus E power minus t. Sure.
No, plus, sir, plus.
Plus t. Okay, next minus 9 by 2, 1 by S, whose Laplace transform is 1 by S. 1, okay, minus 1, oh, this is not 1 by, sorry, this one 11 by 6, one mistake. So 11 by 6. So 11 by 6 into e to the power S plus 2, 1 by S plus 2. So e to the power?
Minus 2t.
Minus 2t. T greater than equals to 0. This is the solution for X of t. Okay, you can rearrange it like that. 9 by 2. Okay, then plus 25 by 3 e to the power t. Then minus 11 by 6 e to the power minus twice t for t greater than equals to 0. This is the solution for X of t. But since simultaneous differential equation, you have to find both xt and yt. So if you go back previous slides, now from 5 you have to find y of s, correct now? So next one, so new one. Okay, now solving for y of s. Okay, what is that? Now y of s is s cube minus 22s square, okay, minus 39s minus 15 divided by, okay, s minus 1 into s plus 1 into s plus 2. And now the same procedure. Partial fraction, then take inverse Laplace transform, then take inverse Laplace transform, you will get y of t in terms of t is the solution for y of t. Correct now? So this is the solution for y. Okay, not y of t. This is solution for y. Correct now? So this part left for you. You have to solve it. Okay. So ultimately, okay. Therefore, the solution to the given simultaneous differential equation is correct, x of t, y of t. For your information, I will write here both the answer 9 by 2 minus 11 by 6 e to the power minus twice t plus 25 by 3 e to the power t. Here it is 15 by 2, okay, plus half of e to the power minus t plus 11 by 2 e to the power minus twice t minus 25 by 2 e to the power t. This is the solution for t greater than equals to 0. Just wait. Why I have written this one? I will show something different thing. Okay, so that's right. Now here this step I have not done. Okay, now here it is directly I have written the solution y of t. Why? Now in the previous step, okay, in the previous section we have already discussed how to find x of s, and you already know. Okay, you have already studied so many times. Okay, now how to solve the y of s. Correct now? That means how to find the inverse Laplace transform. Okay, so this one will take some time. Correct. This is one step. Now I will give you another step here. Okay, now. So what is that? Instead of finding the inverse Laplace transform of this one, y of s, you can find y of t. Okay, you can skip this one, this part. Sorry, you can skip this part easily. You can omit this one. Okay, and in different way you can find y of t. What is that one? Actually, just I will tell you. Now you have x of t. Correct. Up to this one you have to do. I repeat. Are you following me? What I am telling? Hello. It is your okay. You have now x of t with you. Okay, now this one up to this one is okay. Up to this one is correct.
Yes, sir.
Yeah, this is up to this one is okay. Okay, so this one you have to find, of course, up to this one, and after that you no need to solve for y of s, not y of s, which one we have done for this problem. Okay, now here no need to do that one. What we have to do now? This x of t, okay, you can put here. Okay, where you can put this one. Okay, here in this equation, and then you can find the t. Okay, so you can find the y of t. Correct. So what is that one? Sorry. So this is the answer, x of t minus 9 by 2 plus 25 by 3 e to the power t minus 11 by 6 minus e to the power minus twice t. So this is our known one. Okay, now. So just what is the given? So the equation number 1. So this is the given system of equation. Okay. So given system of equation is this one. So now actually our target is to find y of t using this one and this one, this part. So you write down this one. What is the number? Previous one is 4, 5. So it is 6. So 6. So equation number 6. Okay, so this is one way. Next way, that is, I will write it is not only. Okay, alternative process. Okay, to obtain the y of t, okay, having already, okay, having obtained x of t, okay, already you have this one. Okay, now using equation 1 and what is the equation 1 and 6, 1 and 6, 1 and 6, 1 and 6, okay, 1 and 6 by eliminating, okay, dx by dt, okay, from the equation 1. So what is our answer? X of t, we have now, we have the solution. X of t equals to, what is the answer? Minus 9 by 2 plus, minus 11 by 6 e to the power minus 2 t plus 25 by 3 e to the power t. I repeat, we are just simply skipping. I will go to the previous, this step. We are not going to find this one, this step. Okay, instead of this one, we are up to the previous one, up to this one is okay, up to this page. Next page, this one for solving for y of s. Okay, instead of that one, we are doing this one. So anyone you can do. So now we have x of t. So what is the dx by dt from here? 0. Okay, then minus 11 by 6 into 2 e to the minus 2 into e to the power minus 2 t plus 25 by 3 e to the power t. So the answer is 11 by 3, correct? E to the power minus 2 t plus 25 by 3 e to the power t. So this is the, so x and t, x of t and y of t both are now known. Okay, and equation 1 actually, okay, anywhere equation 1, okay, so x of t equation 1 is better, x of t e to the power 1 is only, okay, you can put anywhere, either first equation or second equation, anywhere. Okay, so now we will write, okay, so if you just see what we are going to write. So dx t is this one. So we get, so from equation 1 we get, you can put anyone, either one, first equation or second equation, both are x, actually function of x and y, okay, instead of t, with independent variable t. So if you put over there, then what will be your answer? 2y equals to dx by dt minus 4x minus 3 e to the power minus t, this one. Okay, now you just see dx dt, what is that one actually? So this one, what is the meaning? This is the dx dt, this is the dx dt, this is the x. So what is the meaning here? It is dx by dt minus 4x of t, meaning all are t are there. Okay, so minus 3 e to the power minus t. So directly here you can write, this is the form. So dx by dt is the earlier one. So 11 by 3 e to the power minus 2 t plus 25 by 3 e to the power t minus 4 times of x, 4 times of x, 4 times of x, this one, x of t. So minus 9 by 2 minus 11 by 6 e to the power minus 2 t plus 25 by 3 e to the power t minus 3 e to the power minus t. So this is the solution for y. So if you simplify, okay, I will not go the next slide. Okay, I will erase here. Okay, so now I will erase here and I will write directly the y of t here. Correct. So this is now. Okay, so what will be the answer? Y of t. So this is actually y of t. Y of t. So y of t equals to half of the full one. Okay. So I will write half right now. So multiply the find the all. Okay. So the answer is y. You will like that. Okay. So simplify it. So our answer is 15. Okay. 15 plus minus t, simplify 11 to the power minus 2xt minus 25 to the power t. So this one. So what is the answer? Ultimately, y of t equals to 15 by 2 plus e to the power minus t by 2 plus 11 by 2 to the power minus 2xt minus 25 by 2 e to the power t. So these two together, x and t and y of t, x and y of t are the solution. Okay, so this is the another way to find the y of t, but x of t, the procedure is same. Okay, that's all also okay. You can find y of t and then find the x of t by replacing x value, sorry, y value and y dash value. That is also okay. So this is the procedure. Anyone for y of t, you can directly for y of s. Okay, you can solve y of s and then find y of t. Otherwise, you use x of y of x of t, the already evaluated value, that one, and then find y of t. So any one of these two. But for either x of t or y of t, any one you have to find, okay, as per our actually steps we have already discussed. Okay, so now last one, write down few problems. What is the time? Okay, so now you write down the problems. Okay, now homework.
Sir?
Yes, write down the homework.
Sir, is that the only way that we can solve that question?
Once again, you tell me.
Is that the only method that we can use to solve that question?
No. You can solve a lot of procedures are there, but using Laplace transform, what I actually discussed, that one. So
okay, sir.
Using Laplace transform for the simultaneous differential equation, what is the step? Okay, take Laplace transform first. Okay, then here up to this one is okay. Then then solve the algebraic equation. Okay, algebraic equation. So from this one, Laplace transform, differential equation. Okay, ODE, you will get algebraic equation. Solve that one. Then third step is, okay, solve for x of s. Okay, using inverse Laplace transform. The fourth step is, this is the change, here only change. Solve for y of s. Here it is using, so 4 will be two part. Okay, using inverse Laplace transform or use x of t from step 3 to find y of t. So these are the steps. This one you have to do, this one also you have to do, this one either you have to do this one x of s or y of s. It is your choice. And if you put or, then here also it will change x of s algorithm. Okay, now here also you have to find x of t then plus. So this is, so now write down the, okay, ordinary differential equation. Now, that is dx by dt. And now for your homework, I will give you the d2x by dt2 also. So 1, 2, dx dt. Okay, I have not written it, but it is homework, so you have to use Laplace transform. Okay, so use the Laplace transform to solve that one. So 2xt minus 2y dashed, that better to write, so it will be first name. Two x dot minus 2y dot minus 9y equals to e to the power minus 2xt. Second equation. Okay, 2x dot plus 4y dot plus 4x minus 37y equals to 0. Okay, subject to x equals to 0, y equals to 0, sorry, y equals to 1 by 4 at t equals to 0. Question number 2. Okay, this one, 3 x dot plus y dot minus 2x equals to 3 sine t plus 5 cos of t. Okay, plus 5 cos of t. Second equation, 2x dot plus y dot plus y equals to sine t, okay, plus cos of t. Subject to condition or subject to x equals to 0, y equals to minus 1, okay, minus 1 at t equals to 0. Third equation, okay, third equation, x double dot, okay, equals to y minus 2x and y double dot equals to x minus 2y, subject to conditions. Okay, x equals to 4, y equals to 2, x dot equals to 0, y dot equals to 0, okay, at t equals to 0. Last question, fourth one. Okay, so this one is like that, 5x double dot is okay, double dot, okay, plus 12y double dot plus 6x equals to 0. Another one is 5y double dot plus 16, x double dot plus 16y double dot plus 6y equals to 0, okay. Subject to conditions, you need 4 conditions. So subject to conditions, x equals to 7 by 4, y equals to 1, x dot equals to y dot equals to 0 at t equals to 0. These are the 4 homework. Do you have any doubt? So that's all. So I will check at least one homework. Okay.
Okay, sir.
Tomorrow, day after tomorrow. Okay.
Okay,
Or
sir.
else, no, wait. I wait for just 1 minute. Right now, only 27 minus 2. So 25 students are there. Okay, now. So you have to send this. Don't inform anyone. Okay, now. I need only 25 answer. So you just according to your roll number. Okay, you choose one and send to me today itself. So what is that one? So roll number 1 for this one, roll number 2, 3, 4, 5, okay, 6, 7, 8, and so on. In that way, you search your problem and solve, and then send to my Gmail. Up to today, maybe evening 6 o'clock. Okay, now before 6 o'clock. My email ID, this email ID, not other. drgsm, okay, phd @gmail.com. I'm taking the class using this one only. drgsm phd, small, all are small. Okay. So you send your answer through this email ID only. Okay. Only 25 answer I will take. Okay. Answer sheet. Clear? Okay, you can leave the meeting now.
Sir, total 35 are there, sir.
Yes,
Yeah.
sir. 35 people are there.
Plus 27 plus 27 minus 2, me and my presentation. Is it? Okay, 27. Yeah, 27. That means, okay. 36. Including me, bhai, 36. You are.
Sir, 34, sir, then.
Then
Student.
34. Yeah, 34 only. Sorry. Then not 25, 34 only. I will consider only 34 answer sheet. Okay. Don't inform anyone. You can leave the meeting now. If you have not written, you can write the question paper. Okay. Okay.
Thank you, sir.
Before 6 o'clock, right?